Hey guys, let me share with you the answer for 5.4a. So 5.4a, it says that as soon as they start talking with each other, well, what we're trying to do is determine whether there is a benefit to trade, if there's gains from trade that can happen in any of these situations. Part A, it says as soon as they start talking with one another, they find they own exactly the same amount of each good as the other does. So if you recall, the key component for being able to have gains from trade is have different MRSs, different marginal rates of substitution. So if we can imagine these two people, they might have the same exact bundle right here, but let's say one individual's indifference curve through that point looks like this, and another individual's indifference curve through that point looks like that. Well, as you can see, there are different MRSs, and this person is willing to give up more of x2 for x1 than this person is asking to take. So definitely, if they have the same point, they're still able to have gains from trade. Now, if both of these people had the exact same indifference curve and they were on the exact same point, then there would not be any gains from trade. Okay, B says they discover that they are long-lost twins that have identical tastes. So this is kind of similar to the first one, or really what I just said. Let's say that they have some identical tastes, and it's represented by this preference map. Now, like I just said before, the only time having there would be no gains from trade is if you have identical tastes and you're at the identical point. It doesn't say that they're at the identical point. Let's say one person's down here and one person's up here. They have different levels of happiness, same indifference map, same tastes, different bundles, different levels of happiness. You can see that the MRSs are different, so therefore there must be some point where, hey, this person gains a little bit, this person gives up a little bit, gains a little bit in this direction, gains a little bit in this direction, and hey, you can see that both individuals are on a higher indifference curve than they started. All right. C says the goods are perfect substitutes for each of them with the same MRS within and across their indifference maps. Okay, so this one is tricky. There is no gains from trade here. And the reason why is because if they have the same MRSs, then their indifference curves are going to look like this, the same MRS. And then, as long as they face the same prices, which clearly they do in the same market, they're going to have budget constraints with the same slope. So let's just say that one person's budget constraint is like this, they're less rich, this other person's budget constraint looks like that. You can see their optimal bundles are here, both of them here on the corner. Both of them would like to get even more of this good, x1, and give up x2. There is no x2 to give up. So in this case, they cannot trade. All right, finally, they have the same tastes. They own different bundles of goods, but are currently located on the same indifference curve. So, all right, we have the same tastes, and they're on the same indifference curve. So this is kind of easy to draw. But now, the important thing to note is they have different bundles. So one person's maybe located here, one person's located here. Right off the bat, you can see they have different MRSs. But you can also see that, hey, if they just have some sort of an average, they're like, hey, why don't we make your bundle be 30% mine and 70% yours, and my bundle will be 70% mine and 30% yours. They can both get to some bundle in here that will put both of them on a higher indifference curve. All right, so there still is gains from trade in this situation. Hey guys, now I want to do 5.8. Part A, we're talking about this tastes for a good Austrian candy called Mozartkugeln, apparently. Alright, so suppose that the only factor determining my willingness to pay for additional Mozartkugeln is how many I already have. Okay, so already your brain should go, that sounds a whole lot like something quasi-linear if only one thing determines my MRS. And we'll see that is in fact true. Okay, part A. Suppose you know that I'm willing to give up $1 of other consumption to get one more Mozartkugeln when I consume bundle A, which is 100 Mozartkugeln and 500 in other goods. So it's 100, 500. So this is going to be called A. And also one more thing I know. I know that my marginal rate of substitution is $1 more. I'm willing to give up to get one more Mozart Kugel. I'm willing to give up $1 of all others consumption. That is telling me that the slope of the indifference curve, i.e. my MRS, at this point is -1. Okay, just to point that out. All right, and so what is my MRS when my Mozart Kugel consumption remains unchanged from bundle A, but I consume only $200 per month in other goods? So this is this bundle here, and what do I know? If I know the slope is -1 here, and the only thing that changes my MRS is how much Mozart Kugel I am able to eat, then I know that my MRS is -1 here at this point also, okay? So the MRS here is -1, and the MRS at this bundle also is -1. In other words, I could draw a vertical line, and on every indifference curve that I hit the same MRS. What does that sound like? That sounds like, okay, part B, quasi-linear in Mozart Kugel, which is the answer to part B. Are my tastes quasi-linear? So they're definitely quasi-linear in Mozart Kugel. We don't know anything about consumption, and actually we'll see that they won't be quasi-linear in consumption. Could they be homothetic? Well, homothetic, don't forget, is where you write a ray out from the origin, you hit the same MRS. The only way that they could be homothetic and quasi-linear is if you had perfectly straight indifference curves and they were perfect substitutes. Right now we don't know if they're perfect substitutes or not, but they could be. In a second here I'll show you that they're not perfect substitutes. Okay, number C, excuse me. You notice that this month I'm consuming bundle B, which is $600 in other goods and only 25 Mozart Kugel. So let's put a B here. Okay. And when questioning me about my change in behavior from bundle A, you observe that I am just as happy as I was before. So B and A must lie on the same indifference curve. The following month you observe that I consume bundle C, 400 Mozart Kugel and 300 in all other goods. So that's right here. Okay. Does my new information about B and C change your answer in the above section? Well, look, you can totally see that this indifference curve, in order to go through all of them, must be curved. So is it perfect substitutes? No. So it cannot be homothetic because only perfect substitutes can be both homothetic and quasi-linear, right? If they were perfectly straight. So we know that it is just quasi-linear in Mozart Kugel and is not homothetic. All right. And furthermore, is consumption other than Mozart Kugel essential for me? So is this consumption essential? What does essential mean? Essential means that the good on the other, the indifference curve crosses the other axis. So if I'm asking if C is essential, that means does this indifference curve ever touch this axis? Sure it does. Let's keep drawing lower indifference curves. Hey, what about this one? Eventually you're going to hit the axis here. If you keep sliding down, that's how quasi-linear works, and that means that C is an essential good for me. Okay? Excuse me, C is a non-essential good for me because it crosses this axis. So consumption is a non-essential good. Let's now move to B, the mathematical section of it. All right, so first we know that we're given a utility function which is equal to 20x1 to the 0.5, where x1 is Mozart Kugel, and plus x2. Hopefully you look at that and you can see right away that since that's additive, that is a quasi-linear in x1 utility function. All right, part A asks us to calculate the MRS. The MRS is negative partial u partial x1 over partial u partial x2, which is equal to, let's take the derivative of this with respect to x1. The derivative of a sum is the sum of the derivatives, so it's going to be this piece. Bring the 0.5 down, so I've got 0.5 times 20 times x1 to the negative 0.5 plus 0. With respect to x1, I'll just leave that there. With respect to x2, this piece is 0, this is 1, so that is equal to 0.5 times 20 is 10 over negative 10 over x1. I'll bring this down, it'll be x1 to the 0.5, okay? So that is the MRS. Now, it's asking in part B, it says, consider the bundles A, B, and C as defined earlier. Verify that they lie on the same indifference curve when tastes are described by the utility function. Remember, we heard earlier that all three of these tastes were on the same indifference curve. So let's go ahead and plug in the utility of, let's do this one first, A, which is 100, 500. I've got 100, 500. If I plug that in, that's 20 times 100 to the 0.5 times 100 to the half power plus 500. That's equal to, it's 20. It's 20 times 100 to the 0.5. 100 to the 0.5 is 10, so that's where the 200 comes in, sorry. Plus 500 equals 700, okay? I'll let you do the exact same things for B and C, and you'll see you'll get 700 for that as well. All right, part C says verify that the MRS at bundle A is as described in part A, where the MRS, remember I told you, is actually -1. How do I know that? Because I was told in part A that I'm willing to give up $1 on all of the other consumption to get another Mozartkugeln. Okay, all right, so let's go ahead and do that. The MRS at part A would be equal to, what's the MRS? -10 over however much x1 I have, which is 100, to the 0.5. That's equal to -10 over 10, which is equal to -1. So it is, in fact, true. The MRS at point A is equal to -1. Now derive the MRS at bundles B and C. At point B and C, if I look at the MRS at point B, I do the same thing. I just plug in, for B, I plug in 25 here, and when I plug in 25, I get -2. And the MRS at point C, when I plug in point C, which is 400 here, I get -1/2. As you can see, here's another key that this is quasi-linear in x1, because x1 is the only good that shows up in the MRS. Okay, next question, D. Verify that the MRS at the bundle 100, 200, which was this one where I dropped my consumption, corresponds to your answer in AA, which was -1. And again, if I look at it, the MRS here only is a function of 100, so if I plug 100 into here, you're going to get -10 over 10. You're going to get a -1 MRS here and a -1 MRS there, which is what we had discussed earlier in the solution. All right. How much other goods, this is part E, how much other goods consumption occurs on the indifference curve that contains 100, 200, this one right here, when my Mozartkugeln consumption falls to 25. So I'm around here somewhere, okay, and we want to know how high to go. Well, let's first calculate the utility of 100, 200. This point right here. And then we know the utility's got to be the same. And so if I'm at 25, how high of other consumption must I have to still get the same amount of utility? All right, so at this point, I'm going to have 20 times x1, which is 100, to the 0.5, plus x2, which is 200. So that's 200 plus 200, that's equal to 400. Okay, now my utility when I drop to 25 Mozartkugeln, and how much other is going to be this: 20 times 25 to the 0.5 plus how much other? Well, that's got to all equal to 400 some way, right? So how much is the question mark got to be? Well, I could solve this out, or I can just kind of reason this out. 25 to the 1/2 power is 5. 20 times 5 is 100. So all other consumption must be equal to 300 in order to get 100 plus 300 equals to 400. So this, pretty much as we draw on the map, is actually this point right here. It's 25, 300. And that is how much I must have in order to stay on the same indifference curve. On the flip side, what about when it rises to $400 per month? So to stay on this, and it rises to $400 per month, you can kind of see where we're going on the graph. But let's do this right here. Same thing. Let's do when it raises to 400, comma, how much other consumption? So I've got 20 times 400 to the 0.5 plus how much? This has to equal 400 in order to stay on the same indifference curve. Notice that 20 times 400 to the 1/2 power is 20. 20 times 20 is 400. So this must be 0. 0 all other consumption to stay on the same indifference curve. Finally, are Mozart-Kugelin essential for me? Well, in other words, what I'm asking is, do these indifference curves ever cross the C-axis? Okay. Well, let's think about this axis right here. This, remember, is the utility curve. Oh, let's do this one. This is the utility curve, indifference curve that gives me 400. This, by the way, was the indifference curve that gave me 700 happiness. But is there a way to get 400 utility with 0 Mozart-Kugelin? Well, yeah, if you think about it, if you come all the way up here and you consume at this point here, which is 0 Mozart-Kugelin, but 400 all other consumption, your utility will still be 400. So you can see it is possible to come, and this indifference curve crosses right there. It is very possible to have 0 Mozart-Kugelin, which means that Mozart-Kugelin is non-essential, just like consumption is non-essential we found earlier.